The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Okay, so for number 2, we have an integral that seems at first a little tricky, but this is just going to involve u substitution like you learned in Calculus 1, although it's going to be a little bit more difficult to see what you actually need to do once you've done it. So we have let's start with our standard integral, dx over, so we have cube root of x minus 1 to the third power. So what you should call u, in this case, I would think is relatively obvious. You want to do what's inside. However, you might be thinking, when I do the derivative, I'm going to get something that I don't want. I'm going to have x left over. And you are, but we're going to be able to deal with that. So you want to call u equal to the inside of the parentheses. And let's figure out what our substitution for dx is. So du then, remember this is x to the 1/3. This is going to be 1/3 x to the negative 2/3 dx, and if you solve for dx, you're going to get 3x to the 2/3 du. So let's plug all that stuff in. Our integral now becomes, instead of dx, we have 3x to the 2/3 du. On the bottom, we have u to the third. So now we have a problem because our integral is now with respect to u, however we still have x left over. But here's the thing, is that x to the 2/3 can be written in terms of x to the 1/3, and x to the 1/3 was our original u substitution in the first place. So if you recall, some of the tougher problems that you did u substitution on in Calc 1 are ones where you did u substitution and then you had to do it again later in the problem. That's what we're going to have to do here. So if we rearrange this, we get that u plus 1 is equal to x to the 1/3, cube root of x. We have x to the 2/3. That's just squaring these. So x to the 2/3, I'm moving up here in my solution to get away from the other part, is u plus 1 squared. And if you plug that in, you will have only u's. So therefore, and I'll bring the 3 out of the integral, we have u plus 1 squared over u cubed. And now what we can do is factor out or expand the numerator and just put them term by term. That's usually the easiest way to do these. Okay, so this is u squared plus 2u plus 1 excuse me, over u cubed. And that would be u to the negative 1 plus 2u to the negative 2 plus u to the negative 3. If you separated those term by term. And now if we are integrating this du, those are all simple integrals. So to integrate, first we have u to the negative 1. Integral of that is ln u. Next we have 2 to the negative 2. 2u to the negative 2, so remember we add 1 to the power, divide by that new number, it's a negative, so we have minus 2u to the negative 1. And for u to the negative 3, again, add 1 to the power, divide by the new number, which is negative 2. So we get negative 1/2 u to the negative 2. It's indefinite integral, so we have plus c. But we need to put that in for u at the end, obviously. Our answer has to be in terms of x. So we have ln of cube root x minus 1 minus 2 over cube root x minus 1 minus 1 over 2 cube root x minus 1 squared plus c. So I put those negative powers of u in the denominator. Let me clean this up a little bit because it's a little confusing to read. So ln cube root x minus 1 minus those terms plus c, and that's our indefinite integral. So when you're done, recall that we had a 3 in front of the integral. So eventually your answer is going to look like this. You need to have a 3 in front, ln of the cube root of x minus 1, ln of the absolute value of cube root x minus 1, minus 2 over cube root x minus 1, minus 1 over 2 times the cube root of x minus 1 squared. And then all of that is plus c. So recall that if you have a number in front of your integral, it needs to be multiplied times your answer as well.